Most of the 24 hours. Hi, I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in today. Today we're going to talk about server-side performance acceleration, and where we've seen the market really head toward very quickly is leveraging PCIe SSD to accomplish that task. So let's talk about where we are and what the challenges are and kind of where we need to, what we need to do to get from 1.0 to 2.0. So first let's draw up a couple of servers. We'll put those servers on a SAN attached to some storage, right? And so the immediate attraction to PCIe SSD is that we can pinpoint and kind of with the laser strike take care of our performance problem. So what happens is we install a PCIe SSD, and of course that PCIe SSD has a driver, right? And that driver has to support either the OS or the hypervisor that is currently running on this server. And of course we also have a driver for our HBA. And so we do this on all of these. So what we basically have done is installed three very, very fast, locally attached hard drives in these servers, okay? And the challenge with that is that now I need to analyze the data down in my SAN, because we're not going to throw our SAN out, and decide what data down there needs to come up here, okay? Well, one thing we know for sure is we don't have a overflow of IT resources. Guys are stretched thinner than ever. So adding more manual tasks to storage management is generally not very popular. So of course software has leapt in to fix this, and about 2.5 years ago we saw a ton of caching solutions appear on the market pretty rapidly. And so what happens here is we have a caching software that's installed, which essentially is another driver that's installed. Right? And again, that cache has to be per OS or per hypervisor that you're using. So, and what we have seen as a result of all this is a sort of performance sprawl where now we're seeing a PCIe SSD per OS. There tends to be like a favorite almost. So what this leads to is a caching software per operating system or per hypervisor. And so that adds to the complexity. The other challenge that you have here is that these are all siloed. So if, for some reason, if I've got, let's say these are virtual machines and I move a virtual machine from here to here, I've got a challenge in that that virtual machine's cache is now stuck over here, right? So that adds complexity. And the interesting thing is very quickly when we're talking to people, we then introduce more sprawl by either deciding, okay, that's not working real well for us, so we're going to put the cache in the network. Or, that's not where we want to do it. Let's put the cache on the physical host. Or, you know, maybe somewhere on this side of the network. And as you can see, what we end up with now is performance sprawl, because there's no great place to put the cache yet. And we end up with, if you will, driver sprawl, because we've got all these different drivers being installed. So let's talk about, from a 2.0 perspective, what we need to evolve to get to the next generation of server-side acceleration. So in 2.0, what we want is a shared cache environment, so any server can get to any cache. We want it to be transparent to the operating system, so to work with anybody's operating system. And we want a single driver, so we're not loading a stack of drivers. So let's kind of diagram what that might look like. So what we could end up with here is the same set of servers, and then a single HBA that's still on a SAN, but instead the memory is actually on this HBA, if you will. Now that could be done through sort of an interconnect. But the intelligence for managing the cache and everything is integrated between those two. So that way, the driver that actually drives this is the same driver you use to connect to the SAN today. So the same driver you've already qualified is already working for you. So that's key number one. Now the other thing, and what that also means is that driver probably already works across all your OSs and things like that, so it's totally transparent to you. Now you're down to a single stack that you have to deal with. So all of that works. And then the caching intelligence is also built into that board, right? So that way the acceleration componentry is already happening. And because this is living at the SAN level, it all integrates together. So that makes it very transparent and also eliminates all the drivers. Essentially, we get all the work done now on one driver that's already qualified in the environment. Let's talk about sharing, because that becomes very important. As I said before, is if we have a failure here and we lose, or I'm sorry, not a failure, but let's say we move a virtual machine from server 1 to server 3, what do I do with that cache? In most current solutions, at best, what we do is invalidate the cache, and then we have to manually or wait for the process to automatically rebuild the cache on this server. That could take a lot of time that we probably don't want to waste. So what we can do instead is, let's say we have that exact same instance, and we move a VM over here. Well, this is an 8 gig fiber channel SAN. It's got plenty of performance. Why don't we just leverage the fact that we're already on the SAN and go get the cache data right from there? So what you end up building is a cache area network instead of having to copy data back and forth or things like that. We can just go get the cache already from where it is. So this allows you to be in a virtualized environment, to be very nimble still, move virtual machines as needed, and then, but still use this sort of cache area network to go get the data that's there, right? So that makes it much, much easier. So that really brings us to 2.0. And it's something, so the question is, okay, where can we do this? Well, QLogic, as an example, has announced the FabricCast QLE 10,000 SAN adapter that integrates this SSD caching and a SAN adapter all on one card and is ready to go. Thanks for tuning in. I'm George Crump, lead analyst with Storage Switzerland.